Hello and welcome to Start Dev Change. My name is Seth Juarez, and awesome on the other side, socially distant, we have
me. Hi, everyone. I'm Donna Sarkar. Hello. Thank you so much for joining us this morning. We know that this is a weird time, and it's just getting weirder. So we are really grateful you took out time out of your day to come and hang out with us today. So Seth, what are we doing here at Start Dev Change? What's the deal?
Speaking of getting weird, I'm pretty excited. Actually, I've been programming for like 20 some years, and I'm looking over this schedule, and there's stuff that I'm excited to learn about. This is all about learning new things, and whether you're super experienced or you're just getting started, everyone's welcome. And this is super cash, so please make sure to go to, for example, Start Dev Change, the hashtag. If we can go to my screen here, there's a couple of ways for us to actually interact together. We want to make sure that you do that because we're really interested in the interaction. So the hashtag Start Dev Change on Twitter. If you want to go to Learn TV as well, on my screen you can see Microsoft.com learn/TV, or you can go to twitch.tv Microsoft Developer, where you get all of that. But again, we are super excited about the actual interaction. So make sure you interact with us. I'll bring up the Twitter feed every so often, and we can have a fun time learning what you're learning and then learning how to learn with you. A lot of learning going on. What do you think about that, Donna?
That is a lot of learning, dude. That is a lot of learning. So listen, this is going to be a very cool 2 days. So just so you know, you signed yourself up for 2 days of us. Day one, that's today, is all going to be intro to programming stuff, right? And that's going to be introduction to open source, introduction to static web apps, introduction to all sorts of things that are modern tech that people who are creating jobs are looking for talented people to do. So we're not going to be teaching anything that's irrelevant or things that you should have learned 25 years ago. These are all things that are extremely relevant in the world today with very, very viable job opportunities. There's some things on this schedule, like Seth was saying, that are really good for industry veterans like us. I've been an operating systems dev for 15 plus years. That's a long time. So I'm looking at static web apps, which is midday, and thinking, I should learn that. That sounds like a useful thing to learn. Another topic that I'm very interested in is how to contribute to open source projects. It's not something I do. I've worked at a large company for a long time, but I know that that is a really great way to build up my technical resume. So Seth, what are some topics you're interested in? Either today, day one programming, tomorrow, Power Platform.
Yeah, so I'm looking, I got the schedule right here in my hands. There are so many, like, for example, Brian Clark's going to talk about Twitch. I watch Twitch, but I'd love to maybe do a show. I love doing camera stuff.
Yeah.
I'm terrible at it, incidentally. I mean, Donna knows this.
I know.
But for example, intro to languages. Like my favorite class ever was languages, and so I'm excited to see what Shannon's going to talk about. We have intro to VS Code and Node.js. I'm not a big Node.js person, but I'd love to get involved with that. And again, here's one. And look, again, I've been doing this for a long time, but look at this. Working smarter, steps to getting unstuck.
Yep.
That's not a beginner thing. That's a life thing. So I'm pretty excited about that. And then at the end, I think we have a career panel of some amazing folks to talk about what's going on. Then we get to recap at the end. So they let us do whatever we want at the end.
Pretty much.
But again, the reality of the matter is that the most important thing is please interact with us. This is for you. We're all beginners at something, and there's no shame in that. And there are no such thing as dumb questions. Only the dumb people that don't ask them.
This is true. So we highly recommend, whether you're a beginner in tech or a beginner in this specific tech, join us, stick with us, tell everyone. We will assign homework throughout the day, so definitely chime in on Twitter and let us know what you'd like to hear more.
I think it's time.
I think it's time.
I think it's time. Are we ready for Scott Hanselman over there in the back booth? Like a thumbs
All
up.
right.
Scott Hanselman coming up, talking about the art of computers. Let's go to him right now. You're on mute.
Hey, everybody. I'm Scott Hanselman. I'm very excited to be here today, and I really appreciate you've got today and tomorrow 2 wonderful days of great learning with great friends available to you. I am going to give a little keynote here, which is very exciting. This is a new talk that I've been working on that I call The Art of Computers. And the idea with this talk is to give you an understanding about how, or later in career, we'll say, engineers and developers think about computers. You're going to have lots of opportunities to learn from engineers of all levels during this event. I want to encourage you to go and complete some of the interactive learning exercises, check out the videos, practice, get badges and certs and stuff, discover your own path with Microsoft Learn. You can check it out at learn.microsoft.com. It's very exciting, and there's a bunch of interactive learning environments and exercises that you can check out. So what I'm going to talk about today is something that I call the art of computers, because I think that we spend a lot of time thinking about computers, and we think that it is they're magic. It's a science. We hear about computer science a lot, but maybe it's not as magical as you think. This is how I think of it. I've been doing computers now professionally for 30 years and messing around with them for over 40. Here's my first slide. I thought it would be fun to put a slide up with Comic Sans because it bothers people that I use that font, but I think it looks amazing. So I'll go ahead and I'll make that prettier, because when you do computers, you have to use a pretty font. All right. And then, of course, if you're going to do a talk, a keynote, it's something like this, you have to use some like really cool, evocative stock photography. And you also have to be a TikTok influencer. And you can cash me here. So I've got my background, because that's what computer people's rooms look like, right? Isn't that a great example of what the computer person's room looks like? Well, actually, it's not. Here's what my room looks like, because that's really where the real work happens during the pandemic here. But seriously, I welcome you all. I want you to be excited to be here. If you're early in career or later in career, we welcome you to Start Dev Change. And I hope that in general, technology welcomes you warmly. I wanted to show you this wonderful actual magazine cover. This is a magazine cover here. Let's zoom in on that, from March of 1984. And look at this young lady here is on I want to say that's a Texas Instruments TI-89. She's got her bubble gum. She's getting ready to do something with a modem or a mouse there, and she's starting her coding journey. That's really exciting, and that's the kind of feeling that we want people to have when they're getting excited about technology. That's from 1984. Let's get back to that time where everyone felt excited about technology. So here's a question, my friends. When you're starting in tech, what's the trick? Are computers an art, or are they a science? We're going to try to answer that in this little talk here, okay? So as I mentioned before, I've been doing technology now for almost 30 years, but that doesn't make me an expert. That just means that I've had an opportunity to fail a lot and fail comfortably. So I've learned a number of things, and I'm trying to break them down here into kind of 4 categories of how I think about them. When you think about computers, particularly programming them, problem solving is the first thing you think about. We're going to talk about that. Then we're going to talk about what it means to layer things, layering in computers, why layering is important. I see people are arguing in the chat right now about whether it's an art or a science. We'll see, my friends, we'll see. We'll also talk about composition, when you compose solutions together with different things. That happens a lot on the Power Platform. It happens a lot in the cloud with things like Azure, when you compose things together. And then we'll talk about patterns and why patterns are important. So let's start with problem solving. If you're going to be a dev, a programmer, an IT person, a cloud advocate, you need to problem solve at scale. That means asking yes/no questions, the binary search, they call it. Is it this or is it that? If you can eliminate a class of problems, then you can cut them out completely and slowly debug quickly. I'll give you an example. I was presenting recently to a number of young people. They were high school students. And I said, let's learn to program, everybody. I think they were maybe 14. All right, friends, we're all going to learn to program. Bunch of young ladies in the room there. And I said, hey, my toaster is broken. I just hung there. let it be uncomfortable and awkward, waited for someone to help me with my toaster. They're all thinking, I thought I was learning to code. What's going on? Where's the code? Aren't we opening Visual Studio? What's happening? And then someone yelled out, does it have power? Oh, that was great. Someone else said, you should buy a new toaster. That was their solution. And I think that's an okay solution. It's a simple solution, but buy a new toaster was their answer for solving my toaster problem. I just want toast. But someone said, is there power to this toaster? That's a person that's thinking in the terms of systems. Number one thing after all these years is understanding how the system works together. It's the kind of thing that helps you, perhaps, as a technical person or as a burgeoning technical person, explain to your family why the internet's down. Even just knowing to turn the router on and off is an acknowledgement of the larger system at play. So with the toaster not working, I can say, hey, well, there's power involved. Like, there's not just the toaster. The toaster doesn't live alone in the world. One of the other young people said, well, maybe you should plug in something else to confirm if the power is on. And I was like, here we go. Now we're talking. Here we go. Someone in the chat just said, make sure you paid your bill. I love that. That right there is systems thinking. What's not systems thinking is dragging and dropping the text box again and hitting delete and dragging it again and hitting delete and pushing save 5 times. That's just doing the same thing multiple times and expecting a different result. But what we're doing here is we're thinking about how it fits into the system. Did I blow a fuse? Is there any power in the building? And then, I love this, one of the young people yelled out from the back, do the neighbors have power? I didn't even think about that. They said, go out the window and peek out and see if the neighbors are there. Folks in the chat are talking about that. Are the connections there? Are they loose? Like, you would be surprised how many times a loose connection has messed up my web application, which has been a problem. And then one of the final people yelled out that maybe that there was an EMP, an electromagnetic pulse, and the aliens had come, and that was why I couldn't have toast. Turns out I'd blown a fuse. But we spent almost 15 minutes having a really interesting conversation. And what's exciting about this, and why I think it's fun in the chat that people are talking about this, is there's a lot of things that can go wrong. There's a lot of things. We could probably make a list of 100. I love that someone in the chat just suggested that maybe the bread was faulty. We don't know. Could be jammed in there. Could be a rogue Pop-Tart. We don't know. So early in your career, you're going to spend a lot of time Googling with Bing for stuff. You're going to search for things, and that's going to be okay. And then later in your career, you're going to discover that just one question can eliminate a whole class of problems. Maybe they're dumb questions, but just like Seth said at the beginning, there are no dumb questions. There's just the person that doesn't ask them. So we really want to make a welcoming community, both this community here at the conference, but also at the jobs, at the universities, and at the homes that you are going to be a techie at. We want to make a welcoming community where you can ask questions without being judged. Because if an early in career person can ask a question, they can eliminate a whole class of problems. So I love that that Lino in the chat just said it's always DNS. That is actually really true. There's a famous American president who said it's always DNS. DNS is the domain name services that turn a URL like www.microsoft.com or startdevchange.com into an IP address. And as you will find in many, many years of your time on the internet, it's almost always DNS. A lot of my problems I have are trying to figure those things out. I just made a list here in this slide about all the things that I know as an old person to check for. And it's literally just going through that list and checking for those things to make sure that maybe that's what it is. Maybe it's a port. Maybe my certificate's changed. You'll learn about all these kinds of things. My sons and I were watching Sherlock Holmes recently, and someone had murdered someone else. And when then they caught them, they grabbed that person. They said, look, it's her. And they said, no, she was on the other side of town. And immediately Dr. Watson said, oh, There's twins. It's twins. That's how they murdered the guy. There's two of them. Well, I put that in the list as well because it's never twins. Whatever the problem is, it's never actually twins. So be aware of that. So problem solving, super important. That is the thing. Ask questions at scale, yes, no questions as quickly as you can. Super important. Next thing, let's talk about layering. What does layering actually mean? What does it mean to layer a problem or layer a solution in order to solve a problem? Well, layering is vertical, and the intent of layering is to hide complexity from yourself and others. This is a great thing, and this is why computers work at all. We accept that a layer is there to hide complexity, and if the layer works well, we don't worry about what's underneath. An example of good layering would be switching from a manual stick car to an automatic shift car. An amazing example of layering would be like a lift or a ride-sharing system, which abstracts the car away completely. You just get in. You don't even think about the tires and the gas and the car insurance. You're hiding complexity. You could go and write assembly language and do a really low-level application, or you can write a Power Platform application and stand on the shoulders of giants and hide that complexity from others. Folks in the chat are talking about this. How do graphics cards show graphics? They've worked for so long. We just assume that they work. These are really interesting things to think about when we're exploring our new careers in computers. Now, layering, I like to think about, is in fact also lying. You're lying to yourself, and that's okay because you're choosing to lie. You're hiding complexity. And this is really interesting because we can choose to look underneath. We can peel the layer away and see what's underneath that. Here's a really cool example. We've all sent email before, okay? Here's an example of an email. And well, we don't really think about the protocol, like how does it get sent? You push send and the email goes and then it's done. So I just decided to flip this around. I'm just going to take this and I'm going to turn it over and I'm going to show you the other side of the email. And you can see that there's a lot of text there and it's a little bit scary looking, but I see name value pairs. You see how it says from sender to recipient. And you'll notice here that there's some separators. This is the boundary. So I can see what's separating parts of the email. And here's the plain part of the email. And here's the HTML part of the email. So that's interesting. So then you say, okay, Scott, that's cool. Now we understand what email looks like. Well, when you're posting a form, when you're posting an HTML form, look at that. That looks familiar. There's a boundary separating sections of the form from the form data and other things. So an email isn't that far away from a form post. Do you need to know that? No, you don't. That is an interesting piece of trivia. And that's an example of a thing that you really don't need to know until maybe one day you need to know it. Just like you'll be in a ride-sharing car, you'll be in an Uber or a Lyft or a taxi, and one day the tire will pop. It's not really your responsibility to fix that tire, but it's nice if you know how. I'm not a mechanic, but I can change my oil, I can fix a tire, and I can call another ride-sharing service. So finding out that email and HTML forms are basically the same thing, and they're older than I am, is really interesting. So when you're exploring tech, you can discover and learn that all ideas grow out of other ideas. HTML is text that goes over a port. And if you don't know what a port is, that's okay. We can learn about those things later. But email is just the same. It's going over a port. It's using TCP/IP, the transmission control protocol that we use here on the internet. It's all just internet traffic. So when you're making your first Power Platform application and you're going to post forms and you're going to call APIs and you're going to start stitching stuff together, that's what's happening underneath. That's what's really interesting. All these ideas are being reused. On the right here, we have a picture of a record player, of an old Victrola. And there's a needle that touches wax that spins around right there. And that's pretty interesting. And on the left, we have a classic hard drive. They're the same thing. These things are the same. What's happening here is a spinning platter with information encoded on it is transmitting from place to place. In the case of the Victrola, it's happening over sound, and in the case of the hard drive, it's going maybe over some cables. These ideas are the same. That's 150 years apart. Still the same thing. Acknowledging that, thinking about that is really, really interesting. Folks, of course, are arguing in the chat that hard drives and SSDs are different. Indeed, but the idea of the fundamentals of the wheel are still there. It's really interesting. So then when we have these things, available to us, we can start to compose them. We can start talking about composition. And composition allows us to model relationships between systems. And we can say, this has a relationship with another thing. Folks are asking questions like, what's a port? And I apologize for using too much technical language. You can check out my YouTube at computerstufftheydidn'tteachyou.com, and I talk about what ports are and things like that as well. So composition models has relationships. When you compose things, when you plug two things together, or you take this thing and you put it inside that. When you compose a car has a tire, and the tire came from somewhere. These things also are ways of hiding complexity, hiding the complexity of the car, hiding the complexity of the computer, and things like that. And sometimes when things are hidden from you, you can get overwhelmed and frustrated, and then you can choose to dig deeper, or you can choose to ignore it. And that's interesting. Here's a true story. There's a really great show on Netflix, and there's a gentleman on that show who plays an AI. He plays an artificial intelligence. And I got to meet him. He's a lovely gentleman named Chris Connor. He's an actor, and he plays Edgar Allan Poe. So I got to go and interview Edgar Allan Poe, Chris Connor, from Altered Carbon on Netflix. And we met at the Microsoft office. And I went and I recorded a podcast with him. And it was amazing. And I was thinking, this is great. This is the coolest person ever. I want to be this guy's friend. So I'm hanging out with him, and I wrote about this. Here's me looking like a dork and him looking awesome. And then we have a great experience. And then I go back with the SD card, and I plug my SD card in, and this is what I see. Here's the SD card. I kept it because it was such a painful memory. I've got this SD card. And if I zoom in here, you'll see what happened was I had infinite empty folders. I just talked to an actor that I looked up to and recorded an amazing podcast. Yeah, I love it. Someone in the chat said, does it have power? These are the questions that we have to ask ourselves. I felt this in my chest. It hurt. I was like, oh my, I just lost this interview. This is me in my disk looking for my files. It was really, really stressful. And at that point, it's just a black box, right? This SD card is just there, and is the interview in there? I don't know. How deep do I want to go? How much do I want this thing back? Well, pretty badly. A lot of great questions. This is like a toaster question. Our friends in the chat are saying things like file systems. Someone said, always have backups. That's a good question, and I will take that responsibility. Should I have a backup of a thing that happened 10 minutes ago? Maybe. I literally just recorded it, went home, and it was gone. But here's what happened. I looked at my disk in Windows, and it showed me that there was actually used space. So something's there, and it looks like about 300 megabytes, which is about how big an interview would be. So that's something, okay? Now, that's as far as my abilities go. But I know about layering, I know about composition, I know how to search. So I could start thinking about where this could be. And I know that there's bits and bytes, and they're sitting on this disk somewhere. So could I maybe get all of the bytes, lay it out, like give me a dump of every byte that's on this device? So I did that. And I went and I Googled and I binged and I binged and I Googled and I looked for things and I found tools that said that should be this and this should be that. And those are all zeros, and zeros are probably not a good idea in this situation. And it took me a long, long time, many, many hours. And I got deeper and deeper into this thing until I finally found out that my file system was corrupted and it could not be fixed manually. And I ended up learning all about file allocation tables, what's called FAT32. And I also learned that when I recorded my podcast, I didn't record one file, because when I got my file back, it sounded weird. It's going back and forth, and it was like left and right, and it didn't understand what was going on. And it turned out that what happened was the tool that I use records the left side and the right side as a separate file. That was very weird and interesting, but I ended up getting those files back, and I saved the day, and I maintained my friendship with my Netflix friend from Altered Carbon, which was really exciting. So does this mean that I'm some kind of an elite hacker or some cool person who can go and debug stuff? No, it does not. What it means is that I acknowledge that nothing in the computer is hidden, and I just had to ask myself, how far did I want to dig? Think about that for a second. I could have plugged it in, and I could have run check disk or asked Windows to fix it, but I said, I don't trust that. I'm going to go a little deeper. I don't know what I'm doing. I really don't, but I know how to read. And I went through all the different things, and I tried to learn, what is the computer hiding from me? What is layering on top of itself? There's a file system, and underneath that, and underneath that, and underneath that. This is a very simple analogy. I keep coming back to it, this idea of the car. You don't have to be a mechanic. No one here at Start Dev Change is asking you to be a mechanic and know how to build a car from scratch. But there's a couple of interesting and useful things that would be cool. So you're going to learn how to make great applications. It'd be nice to know how to reboot the router. Know a little bit about, how to have a little bit of a network, or maybe set up if DNS or if a URL doesn't look right. You could say, hey, that URL doesn't look right. You get to decide how deep you want to go. We're going to spend our time here talking about applications, but other people in computers and technology decide to go deeper and deeper and deeper and deeper. And if I wanted to, I could probably go and learn those things. I could go and learn about how they put those bits and bytes and electrons on this and how they stay there. But I fortunately didn't have to. I only had to go down one level there to the file system. Is this the same thing as abstraction? I love that question from the Walrus in the chat. That's exactly what this is. Abstraction is hiding complexity. And choosing to deny that abstraction and look underneath it is part of the debugging process. Yeah. Someone's making another great point where they talk about how low do you want to go? Someone had a very funny thing once. Let me see if I find that. Here, I'll just use my keyboard. There was an interview question, and someone said, hey, when you type www.microsoft.com and you press enter, what happens? Some people say, well, the browser makes a request, and it brings back the HTML. And that's a great answer. But I did this interview, and I said, you type Microsoft.com in the browser and you press enter, what happens? And the interviewee says, well, you take the key, and the metal in the key touches the metal underneath it, and then an electron jumps from the one key to the, and then they started going into the atomic level and talking about electrons and neutrons and quarks and stuff. How deep do you want to go? When you're thinking about abstractions, how much do you want to abstract? Is that a good answer? Maybe it wasn't the answer that I wanted, but it's a totally valid answer, because that's exactly what happens when you type Microsoft.com and you press enter. Figuring out what layer you want to live is where your career is going to start. And then finally, the last thing that you want to say and think about are patterns. The other ability that you'll have as you spend more time in technology is the ability to recognize patterns that you've seen before. You go, hey, I had that happen before. That was a mistake that I made before. That's good information. One of the things you'll notice that my stories unfortunately involve me spending many, many hours debugging things. But the fun thing about spending many hours debugging things is you only have to do it once. One time I spent 13 hours debugging a Raspberry Pi. I've got my Raspberry Pi here, not a real Pi, but a computer Pi. Here's a Raspberry Pi. And I was trying to copy a file onto the Raspberry Pi, and everything was great, and it was working, and then it stopped. I was using FTP, and I FTP'd, file transfer protocol, my file onto the Raspberry Pi, and it didn't run. I was finding myself in a classic works on my machine situation. So once again, I decided to go a little deeper, and I learned something. I said, look at all these scary files. What's going on here? And I go, hopefully you'll never have to look at things like this in your career. But I noticed that they were missing stuff. 0D, all the 0Ds were gone from my file. When I compared the one that worked with the one that didn't, I said, this one's missing all the 0Ds. That's super weird. There's one, and there's one, and there's one. Who stole my 0Ds? And why would that be a problem? Well, it turns out that there was a checkbox in my program that said, if you have a file without an extension, you should treat it as ASCII. ASCII means text. So it was taking my program, my binary file, my program, and it was turning it into text. So what does that mean? Why is that a problem? So what? It turned it into text. Well, where have I seen that before? Pattern recognition is so important. Well, 0D is hex for 13. Yeah, someone in the chat says, uncheck it. Yes, I did uncheck it, but I want to know why. 0D is carriage return. Then you find yourself asking the question, what's a carriage? Why is it returning? What's going on? I want to know. Well, it turns out that a carriage is the top part of the typewriter. And when you return it, you pull this return over, and then you spin this and you say line feed. So it's 2020, and we're still thinking about carriage return, bing, line feed, and then you rotate that and feed that. When you think about that, when you're using Git or source control, you'll see carriage returns and line feeds. Isn't it interesting that 100 plus years later, we still think about carriage returns and line feeds? And in my case, those were being stripped out. I've also got a video where I talk about this a little bit. So as I get towards the end here, I want to remind you what we just discussed: problem solving, layering, composition, and patterns. And ask yourself, what can you make now? When you can layer things together, what can you start making with those things? Here's an example of a wonderful, fun thing that I made, and I work on with a lot of friends. And I got to sit on a number of projects and work with this, is an open source artificial pancreas. I'm a diabetic, and diabetics have to take insulin and measure our blood sugar, and it's a whole thing. But once I get my blood sugar from these different implants that I have, I can go and upload them into a database. I could build a Power application on top of them. I could make an API. I turned it into a REST API for my body. So now I have a URL that I can visit that will tell me my blood sugar. And, oh, don't be sorry, friends. I'm not sorry. I appreciate that, though. And then I can make like little screens that have my blood sugar on them. This is a little screen in Python with it's green, showing me that my blood sugar is good. And then I put my blood sugar, with the help of my friend Nate, into the prompt so I can see what folder I'm in and what project I'm working on, and I can see my blood sugar, because that's important to me. Once you have the pieces, once you understand layering, you can start composing things together and doing a lot of fun stuff. So to our question as we end, what's the trick? Are computers art or science? Yes, they are both. That is the trick. You, my friends, can build anything that you want once you accept and understand these basic principles. And I want to remind you, even though I started this talk with the statement that I've been doing tech for 30 years, we're all amateurs. We're all learning. The things that I learned 30 years ago are not the same as the things that I know today. There's no professionals. Someone might say, yeah, I've got 20 years experience. You have to ask yourself, is it the same year's experience 20 times? Maybe they're just repeating themselves. And if Tim Berners-Lee, who invented the World Wide Web, chooses to not put senior web developer at the beginning of his name, he didn't even put the. He could have shown up, hey, what do you do? I'm a web developer. Oh yeah, senior web developer? No, the web developer. I did that. If he can be a web developer, then you can be a web developer too. So go out there, be a Swiss Army knife. It's okay to be a funny little knife that doesn't do anything well. That's what I am. And but focus on the fundamentals. Just at least be a good knife. Don't skimp on the basics. We're so glad that you're here. Thank you so much. And I'm going to throw it back to Donna and Seth in the studio. Thanks, friends.